All right.
Cool. So I've got you, you're unmuted now.
Hey, everybody. All right, we're just gonna start. We're gonna get started very shortly. Yeah, thanks for joining me, and we're going to be doing a little bit of going between what people are saying in the chat and also hey, everybody, what's happening here. All right, we're just gonna start. So we're gonna get started very shortly. I'm hoping that I'll be able to coordinate that through the time. So yeah, the workshop itself is going to be about. We're going to be doing a little bit of break in between, going between what people are saying in the chat and also hey, everybody, what's happening here. All right, we're just gonna start. So we're gonna get started very shortly. I'm hoping that yeah. So there are some people that are tuned in online as well. So yeah, the workshop itself is going to be about. We're going to be doing a little bit. Try to do try my best to going between what people are live and here and also hey, everybody, what's happening. Do the best that I can. All right, we're just gonna start. So we're gonna get started very shortly. I'm hoping that yeah. So there are some people that are today. We're going to be talking about. So yeah, the workshop itself is going to be about. We're going to be doing a little bit. Try to do try my best to going between. First thing that I'm going to do is I'm going to give live and here and also hey, everybody, what's happening. The best that I can. All right, we're just gonna start. So we're gonna get started very shortly. I'm hoping that yeah. So there are some people that are today. We're going to be talking about people to create audio plugins and why I love it. And then what we'll do is we'll get started with creating your first audio plugin. The goal of this is to create something simple, but also to try to explain each part along the way. So for anybody that's getting started with audio programming in C++, there's this intersection of challenges between understanding C++ as a language, understanding JUCE as a framework, or whatever framework you may be working in. And if you're trying to create a plugin or if you're trying to create an audio app, what type of understanding the challenges around that, being able to write the algorithms that you need to be able to do whatever it is that you want to do. Then you have another problem, which is that you get into a little bit later on, which is how do I take the code that I've written and actually create a plugin, create an app, create a distributable that I could actually send to other people and that they can open and that everything installs in the right place and it does what it's supposed to do. There's a whole set of challenges around that. So, so to get started, so I'm going to flip back and forth between my notes and the active project that we're going to work on. So I hope you don't mind that. So first thing is, what is JUCE? So does anybody know? Can anybody describe what JUCE is? I'm going to ask for some audience participation in this workshop. So has anybody ever used JUCE here in the classroom? Okay, a couple people, about half people, 3/4 of the people. Can anybody tell me their best explanation of what they think JUCE is? Anybody? Don't be shy. Go ahead.
There is a guide on JUCE and it involves a lot of like helper functions and it's like a package in C++ for people to
Right. So this gentleman said that it was written by a person named JUCE. His name is actually Julian Storer is the creator of JUCE, and it's a collection of functions that help you write audio plugins. I think that's a great start to a way to describe it. Anybody else have any other ideas? Nobody? Or shy this morning?
Because it's kind of a way of developing common code to explore audio plugins and various formats.
Right. Yeah. So one code base to distribute different types of plugins, different types of operating systems, Anybody else? Jordy?
I was going to say that cross-platform.
Yeah, cross-platform, that's huge as well. Yeah, so all of those things are correct. So my thinking on what JUCE is has kind of evolved over time. So I would describe it as a large collection of libraries. So if you were going to try to, so a lot of people know that typically when you write an audio plugin, the most common language to use is C++, which is of course, a programming language. But if you're going to take and try to write your code from scratch, it would probably take you at least a year, probably much longer than that, just to write the foundation for what you need to do to actually create a plugin. So as one of the people in the classroom said, plugins have different formats. So you have like VST, you have AU, which is audio unit, you have AAX. So these are different plugin formats. And a lot of people don't really think about plugin formats themselves, but they're basically specifications. So when you think about what a plugin is under the hood, it's actually a small app that's running within a larger app, which is normally your DAW. So your DAW is running, and then when you initiate a plugin, it has kind of endpoints that it's expecting to see within the DAW that's letting the DAW know, hey, I'm going to run this application within my DAW. And so those endpoints and what that specification is and what sort of other endpoints that you have, things like plugin parameters. So by parameter, what I mean is, you have some sort of audio algorithm, right? Like let's say it's a filter, and then you have like a filter cutoff, like you want to adjust that. So that would be a parameter, something that you want the user to be able to change, right? So these specifications are different ways that that you're able to indicate to the DAW, these are the parameters that I want the user to be able to adjust. And that's the way that we're able to like do things like draw automation, to be able to make changes on like turning certain parameters on and off within a plugin. So the DAW has to have a certain way that it's able to see what's happening inside of your plugin. So going back to JUCE, JUCE takes those different plugin formats, APIs, they call them, and it essentially writes this foundational layer that sits above all of those plugins, all those plugin formats, so that you're able to hit one button and it simultaneously exports to those different formats. And that's one of the powerful things, and it's able to do that cross-platform as well. So normally, if you had, let's say, a VST3 plugin that you were trying to create, and you wanted to do that for Mac, you wanted to do that from Windows, the way that audio is communicated in a Mac in a Mac operating system as opposed to a Windows operating system is also different. So that's another powerful thing that the JUCE framework has done for us, is that it has taken all of that cross-platform, cross-format behavior, and it's essentially abstracted all of that out. So what you can do is you can just concentrate on writing your product, and that you hit a button, it is able to export to all of the right formats. And that means that there's all of this stuff, all of this complexity that's happening under the hood that we don't even really think about as audio plugin developers, that Jules and the JUCE team have worked really hard to resolve. And so it's a huge endeavor, and that's what makes JUCE so powerful. So Another thing that I'll talk to you about is, and another thing that I think that JUCE does so well is that it gives a window for beginners or people that are just starting to create plugins to be able to start quite quickly without needing a bunch of knowledge. As you gain experience, you find that you need additional control and complexity to do different things. So what I'm referring to in this context is that when you first get started, there's a tool that's called the Producer that is fantastic for getting started and writing your first plugins. So when you're creating a plugin, you have all of these different settings that you can change. So for example, if you talk about a plugin, you know the plugin could be a synth, it could be an effect, it could be a MIDI effect, and you want to communicate. When you're initially setting up your project, you want to be able to communicate all of those things, so that if you're creating an effect plugin, that you're essentially setting up your environment where you're telling your project, I don't need MIDI input, for example. I just want audio to pass through it. I want to do something to the audio, and I want it to output whatever I've done to it. Also, as you get more experience in creating audio plugins, you find, okay, well, if I'm working on a Windows computer and I want to create a Windows plugin, that maybe I want to do a certain thing. If it's a Mac plugin, then I want to do something else. So for instance, you may have some sort of library that's Mac only, and then you need to use different libraries depending on whether you're working on a Mac or on a PC. And you say, okay, if it's Mac, load up this Mac library. If it's PC, load up this PC library. And so those are things that come as you get a little bit further in your journey. And then and what's awesome is that JUCE has this ability to start off to get you started with building plugins quickly, where you don't need all of that additional control. And then it also gives you the ability that once you start getting into your professional journey, that it gives you a path to be able to do that additional complexity. So what you have on the screen right now is what they call the Producer. The Producer is essentially all of the settings that you would normally need to create an audio plugin or an audio app, but they've made this beautiful interface for you where you can actually just check in or check out certain things. Like for instance, we have a project name here. So, what I may call this is, I'll call this Queen Mary plugin. And then it has what you call exporters. So, and for this section called exporters, you have different what they call IDEs, integrated development environments. That's a fancy way for saying the place that you write your code. So in this case, I'm on a Mac, I'm going to be using Xcode, but if you were on PC, you might use something like Microsoft Visual Studio, which is a free IDE for Windows. I actually don't use, so to give you an example of something where the Producer would not work for me in my particular situation, is that I don't actually use Xcode to write most of my code anymore. I actually use another IDE called CLion. But as you can see in my exporter section, there isn't a CLion option here. And so I have to use another system called CMake. So I'll just show you what a CMake, what a CMake file looks like. You don't have to really, it looks very complicated if you're just getting started. But just to give you an idea of what type of path you would have once you start getting further into your audio development journey, it looks something like this. So what you see here with the CMake file is essentially the same thing as what you have in the Producer. It's just that you're typing it out, and it actually has its own language, has its own syntax. So it's almost like learning another language. But you don't have to worry about this for now. But if you see here on line 14, this gives you a good example of something that is very easy to set up if you're using a CMake file, but would be a lot more painful if you were using the Producer, because the Producer isn't really built as well for these types of things. So if Apple, I want to point at a certain folder and I want to do something, or else if I'm on Windows, then I want to point it towards another folder that's a Windows folder. So that's the type of thing that would be super easy if you were using CMake, but if you were actually using the Producer, it wouldn't be the right tool, or it would be a lot tougher to do. But for anybody that's getting started out, the Producer is really awesome. And if I had to start out using CMake, I think that it would just be a lot more challenging. It would have been a lot more challenging if I was starting out there. So if you're just getting started, Producer is a great way to be able to set up your project. So in here you see that there are a bunch of different templates. In this one, I'm going to choose a plugin template. I'm going to do a basic plugin. It does do this thing where if you switch templates, that you have to type in your project name again. So I'm going to type in the title of my project. So I'll call it Queen Mary plugin. Here under modules, so once again, this goes back to this idea that a lot of people think of JUCE as this one big monolithic thing. I would describe it more as a set of libraries, a collection of libraries. And you can see that here under this section called modules, that you have all of these different libraries. So you have like audio basics, audio devices, you have like a DSP library if you want, you have a graphics library. So it's all of these, this collection of libraries. And the nice thing about it is that you can build a complete plugin just using JUCE. So another thing that I missed when I was talking about an overview of JUCE is that it is also an all-encompassing solution, which I think is fantastic. So you don't have to use, so you can use C++ across your plugin if you want to, which I find to be quite easy. So there's this recent wave of developers who want to use a C++ audio engine, along with web technologies like JavaScript, HTML, CSS to build their UI. But I actually like, for now, building my plugin all using C++ and JUCE, and it provides a great way to be able to do that and to do it in a way that's very streamlined, very powerful. Another thing that I should touch on, just going back to audio programming basics, is why we use C++. Why don't we use a language like JavaScript, Python? Does anybody know why C++ is the language of choice for creating audio plugins? Anybody? Low level, yeah. So you got low level control basically. the biggest thing is that C++ is used for what we call real-time audio. Does anybody know what I mean by real-time? Just the word real-time. Anybody? Okay. You're nodding your head, yes. Latency, right. Yeah, so without latency. So that just means that, you know, a great example is video games, right? So you're controlling your character and you're using a controller and you want the character to jump, you hit a button to jump. You want that reaction to feel immediate, right? So you want the character to jump right away. If you hit the jump button and then half a second later the character jumps, that would be very frustrating, right? So same thing if you're using DJ software or if you're playing a synthesizer. It's like when you're playing a synthesizer, if you're playing a piano sampling instrument, you want it to feel as much as possible like a real piano. So when you hit a key, you want to feel that immediate response without latency. So C++ gives that ability. It has a very high priority path. So it's called audio callback. And the audio callback is essentially this high priority thread or this path that is very highly optimized. So you don't get any commands that can like come in and cause the audio callback to hold off for a second. So there are a set of rules that come with what you're able to do or what you should do and what you should not do within what's called your audio callback. And I'll go a little bit further into that a little bit later. All right, any questions? I'm just gonna look here in the chat, see what people are saying. Okay. Yeah, let's. Okay. Great. I will increase the font size when I'm sharing the code. So somebody had asked about Linux, if there are options for audio plugins there. Yes, you can actually build for Linux off of JUCE as well. I don't really know a lot about that particular space, but you are able to do it. So if you want to create a Linux audio plugin, you're able to do that. Great. So I've created a project, and now what I'm going to do is I'm just going to hit this button that says create project. I hit that, and now it wants me to save it to a location. I will just save it to my desktop. And now what it's done is it's taken me to another screen now where I have my project itself. So I'll walk you through what this is. So the first section is what we call a file explorer. So for anybody, I'm going to assume that everybody here has written some type of code of some type. So you have source files in C++. Those are divided between C++ files, CPP files, and header files. And all of those are here. So one of the small wrinkles when you're using the Producer is that if you create new source files, you need to create the files here in the Producer. Okay, if you create them within Xcode or within Microsoft Visual Studio, it won't save, and you'll write all of this source code, and then you'll close your project, and then you come back to your project and you'll say, where are my source files gone? I don't think that it actually deletes them. I think it just doesn't map them properly so when you create your source files, this is the place that you would actually do it. The way that you do that is just this little plus button, and then you can say create new CPP file, create new header file, create a new CPPN header file. So that's the place that you do that, but we won't be worrying about much of that today. Then you get to what's called your modules. So once again, the module is, think of it as library, a collection of functions. and this is the other thing about JUCE as well, is that you have all of these different utilities that you can use to help you make your plugin, that if you weren't using a library or a framework like JUCE, that it would just take you a long time to create all of these from scratch. So for instance, let's say that you're talking about an audio buffer, right? Audio buffer is just this virtual space where you're holding your actual audio, and that you have all of these functions. Like, what if you just want to erase the whole thing? What if you want to add some new values at the end? What if you want to just read what is in the buffer to, to be able to put it into a visualization like a level meter? What if you want to change what's in the audio buffer somehow with an audio algorithm? So you have the audio that comes in, you want to have some sort of audio effect that changes the audio, and then you want the resulting audio to come out of the audio buffer. So it has facilities to be able to do that. So if you weren't using a library like JUCE, you can still do that, of course, but it's just a lot lower level. And JUCE has this great way of just being able to do that, and also being able to take off. I think another thing that JUCE does really well is that, for me, it's removed a lot of the harder edges of the rougher edges of C++. So if you're just doing raw C++ without any libraries, without any, if you're just doing it from scratch, what I found is that it's a very strict language, and if you're not typing exactly what the compiler is expecting, then it can be a little bit cruel to you and just tell you that you're wrong and that you're not doing it right. Whereas I've found that using JUCE seems to be a little bit more straightforward, and the way that it's written with a lot of thought, and just really intelligently and well thought out. So as I was saying, these modules, these are different libraries that you have. Then you have what are called your exporters, or what some people may call your generators. So this is where you actually write your code. So in this case, we're going to be using Xcode. Then you have what's called debug and release build modes, and we're not going to worry about really discussing that. But what I'm going to do is I'm going to hit this button that allows you to open up your project in Xcode. So just hit the central button up here at the top. It says save and open in IDE. I hit that, and now what it's done is it's opened up Xcode for me. And we can see our source files here, the plugin processor and plugin editor. And we can see the different modules there as well, if we want to look into those. Does anybody have any questions to start off with? Anybody have any questions so far about what I've covered? Once you've hit what? Create project. Yes. So if you have more than one option, so I think so the question was, can you change your exporter once you've actually created your project? And the answer is, if you have something that's supported in the producer, if you have an IDE that's supported in the producer, then yes, you could export it. I'm not sure what for Mac, the only option that you really have is Xcode, but I think there may be 2 or 3 options for Windows, but I can't remember. So you have Visual Studio. Oh, there's Visual Studio 2022. There's Visual Studio 2019, which are slightly different, Okay, so that's an example of two different exporters, and you can select which exporter that you would want to use in that case. That's another one of those things that if you're in CMake, you can actually select any, you can write your code pretty much anywhere. If you want to use Visual Studio Code, if you want to use Visual Studio, if you want to use Xcode, if you want to use CLion, if you want to write your C++ code in the command line itself, which, believe it or not, some people still do. You can do all of those things, and you can set up all different types. You can basically set it up any way that you want to, if you know how, of course. But in this case, we'll use Xcode. Okay, so the next question is, does anybody know what the difference between a plugin processor and a plugin editor is? Anybody? Okay, this is good. Yeah, go ahead. Yeah, just a guess. Okay, that's all right. Yeah, exactly. So the editor is what we call the GUI, the user interface, and the processor is for what's called audio processing. Were you going to say something? Same thing? Okay, good. Yeah, so typically in a plugin or within any application, right, you have well, it depends on what philosophy that you're following. But in this scenario, you have two sides to your plugin. You have the processing side, which is where the audio processing happens. That's where you're controlling what the audio buffer does. That's where you write, where you actually write your DSP code. It's where you define what they call your data model, which is the part that the user does not see. Think of it like the back end of a web page, right? So you have different, so you have the UI, right, where the user types in their name and they type in their password and they hit enter. They have a button where they hit login or they hit enter, and then once that happens, then all of this stuff happens on the back end, right? Like, okay, is the password correct? Okay, is the user an authorized user? And then it says, okay, if yes, take me to, my home screen, or no, tell the user that the password is incorrect and just keep them on the login page. Okay, so the editor is what the user sees. The processor is all of the stuff that's happening under the hood. So some people really like this because it's simple. Lately, what I've been finding is that I've been moving more towards what they call, this is a little bit more of a segue, but I've been moving a little bit lately towards what they call an MVC type of architecture and using JUCE in that way, which is more that you have the model. So the model is the same thing as the processor where all of the audio processing is happening. You have the view. So M is model, V stands for view, which is what the user sees. And then you have this other layer, this intermediary layer called a controller, which is where this part in the middle that controls the interaction between what happens with the view and what happens with the model. So to give you an idea of the login screen with an MVC model, then the model is maybe the place where you actually have the login logic. The view, of course, is the user interface, and then the controller may be that layer that dictates what happens in that logic, where it says, if user logged in correctly, if user logged in correctly, show home screen. If incorrectly, then return to the login screen. So That's something that I've started to do lately. But I think once again, if you're just getting started out, that this plugin editor and plugin processor type of architecture works really great. And that's essentially what you have. So now I'm going to take you a little bit further in towards what the processor is. So we'll start out with the processor. I'm going to make my font a little bit bigger. Any questions about any of that? Yeah. Uh-huh. So you're talking about this where you okay. So let's go back there. I'll repeat the question, by the way, once he's asked it. So okay, you're talking about this side?
Yeah.
Uh-huh.
So I think from if we're like following along.
Uh-huh. Yeah. Okay. Yeah. So he was saying that if he's following along from the producer, he just missed how you get started. So do you see at the top center how you have that button up at the very top center that says, and once you hover over it, it will say save and open in IDE. So you just hit that button. Okay. So just talking about this button right here. And right beside that, you have that selected exporter button. So if you had a couple of different options in your exporters, you could change what your exporter is there. So if you were, you look like you're on a PC. So if you have, oh, you're on a Mac. Okay, so then you're good. It should be Xcode in that case. But if you were on a PC, you would be able, and you had Visual Studio 2019 and Visual Studio 2022, you would be able to select that here. Okay, and once you hit that, then that should just open you up into this screen. Okay, any other questions? You look like you have a question. Yeah. Yeah, so he was saying that he would expect Sea Lion to be an exporter. I think I don't know the specific reason for that, but I think that the main reason for that is that Sea Lion can natively read a CMake file. So has anybody used CMake before here in the room? No? Okay. So normally if you're using a CMake file and Xcode, what you need to do is you actually need to put in a command to create an Xcode project. It's kind of like the button that you hit where you hit save and load in IDE. What it does in the background is that it actually takes the settings that you put in the producer, and what it does is it creates a new Xcode project that now loads. Okay. And if you were using CMake, then there would be a command that you would manually type in to do that. It's like a build command. Sea Lion, one of the things that I love about Sea Lion as a person who's been using CMake lately is that it can actually load a project without needing to use any of those special commands. So you can actually just point it towards a project that you can point it towards a piece of source code that has a CMake file in it, and you can just say, just read the CMake file and just load my stuff, and it just does that, and it's magic, and it's super awesome. I love that about Sea Lion. But yeah, what the producer does is that abstracts all of that out for you, because when you look at, for instance, if you look at this in this project, which is my own project, what you have here is you can see the difference between what this has versus what this we just created. You can see that it has this Queen Mary plugin .juicer in there, which loads the ProJuicer. But you can see that in my own plugin, we don't have that. We just have this CMake list.txt. So there's no like Xcode project. There's no CLion project per se. It's just this CMake list that gives instructions on how it needs to load a project. So what I could do is I could just open up CLion and point it at this folder that contains this CMake list.txt and say, okay, you know what to do, and it'll do it. And it actually has another thing is that it actually has debugging for CMake as well, which you don't normally have if you were just using Xcode. So like I was saying, CMake is its own language. It has its own instructions and syntax and things. And if you're trying to debug that without anything really telling you it does tell you what's going wrong, but sometimes you just have to really read through the logs to really figure out what's happening. But the ProJuicer just abstracts all of that out, and it lets you modify your settings, from this nice little interface. Any other questions? Anybody? Okay. So now I'm going to go a little bit more into the plugin processor versus the plugin editor itself. So if it's your first time loading up a C++ project or loading up a JUCE project, this can look pretty intimidating. What I'll do is I will give an overview of the most common places where you will actually write any type of code. So the most important places that you'll be writing your code. So a lot of this you can actually ignore, and that you don't actually change, and it's basically like scaffolding. So things like get name, accepts MIDI, produces MIDI, is MIDI effect. All of those are actually changed by the settings that you make in the ProJuicer itself. So if I go here into the ProJuicer and go into this little settings sprocket here, for instance, we have this field called project name, and that is what actually JUCE plugin name is, or at least I think so. Where it actually, so you'll never actually have to you'll never actually have to change this. Accepts MIDI. So if you go to plugin characteristics and I change MIDI input and I check that in and say plugin MIDI input, then that would change what happens here. It's then JUCE plugin once MIDI input would, in that case, return true. But once again, this is not code that you would ever modify. I've never touched any of this. So the first place so I'll point you to a couple different places where you actually would normally write code. The first place is what you call the constructor. Okay, so it's a constructor because normally it looks something like this. So the name of this class, I'm going to assume you know what a class is called Queen Mary plugin audio processor. So you can tell it's a constructor because it normally it will have the same name as what the class is. So it says Queen Mary plugin audio processor, : Queen Mary plugin audio processor, and then parentheses. Does anybody know what the constructor does? Anybody? What's that? In general, yeah. What does a C++ constructor do? Finds. Right. Yeah. So has anybody used anything like P5JS or processing at all? Right. So you have this. So in P5JS, you normally have like this setup, the setup function, which only runs once, and then you have process, which is run continually. So think of a plugin constructor like you were saying. It's your setup. It's your setup. It's the thing that it only runs once. It only runs when the object, which is an instance of this class, is first instantiated. So it only happens once. So once the object is created, it never happens again. Okay. How about this? And so that's where you would write any sort of things that you would just need to happen once, or just define one time. Okay. And we'll do that a little bit later. Okay. What about this second function that has this? So it's the same as the constructor, but it has a tilde in front of it. Okay. Does anybody know what that is? Destructor. Okay. And what does a destructor do? Right. So exactly. So like he said, like cleanup code. So when the object needs to shut down or it needs to delete, this is code. Sometimes you have certain objects or certain things that need to happen before the object can actually destroy itself, and destruct and basically say and clear its memory. So it's this place where back in the old days of C++, when they did manual memory management, what you would do is you would create memory, and then what you would need to do in your destructor or someplace in your code is you would need to have a place where you would actually get rid of that memory and deallocate it. So a lot of times that would happen in the destructor. Okay. So the next section that we'll go down to, like I said, a lot of these functions, I've never actually done anything with them. Get current program, set current program, that's all kind of scaffolding. So the next one is prepare to play, and the JUCE team have been nice enough to give you a little bit of a cheat here by providing a comment. So prepare to play. Can anybody give an example of something that you would need to do, that you would need to put in prepare to play? So can anybody give an example of something that, this is a little bit of a tricky question, especially if you've never written JUCE code before, of something that would need to be put in prepare to play? Anybody? Okay. Yes, Jordy.
Maybe have some filter code that has like a filter cutoff and frequency, and you need to convert between the sample rate and frequency.
Right. So filter code. So converting between sample rate and frequency is a good one. So anything where you need to communicate the sample rate, right? So like Jordy was saying, filter code is a great example of something that you need to know whether the DSP algorithm that you've written, the filter algorithm, needs to compute 44,100 values per second or 48,000 values per second. Okay. So any type of DSP algorithm normally has some type of prepare prepare to play, reset type of function where you're normally passing in the sample rate and the buffer size. Okay. Does anybody know what a buffer size is and how buffer size affects what is just affects your plugin? Anybody? Like think about what happens in your DAW if you adjust the sample rate. What does that do? Go. Yeah. So how many samples you're processing at one particular moment in time, every time that you do what? Does anybody know? Probably not. So anytime you do an audio callback, okay? So this is the thing that adjusts how many samples that we're trying to compute for an audio within one audio callback. So when the audio callback, which I'll show you in a moment, actually does one round of processing, the buffer size says, okay, are we trying to look at 64 64 values per second? Are we trying to look at 512 values? Not per second, sorry, per callback. So that defines how much information you're trying to process at once. Okay. So if you were trying to get a faster response, would you want a larger buffer size or a smaller buffer size? Anybody know? Smaller buffer size, right? Yeah. So what happens is, if you think about it, right? So sample rate, does anybody know what a sample rate is? So what's a sample rate? Yes. So how many samples you need to process in a second? So yeah, 44,100, 48,000, 96,000 per second. So if you need to process 44,100 samples in 1 second, and your buffer size was 64, would the audio callback need to call more times or less times than if the buffer size was 256 samples per callback? Anybody know? So 64 samples versus 256 values, or 256 samples. Which one is working the computer harder? 64, right? Because you need to process it much faster to get to that 44,100 samples in 1 second, right? So that's why if you're trying to tighten down, if you're trying to get a faster response, then you would use a smaller buffer size. Okay, but of course, smaller buffer size means that the computer needs to work harder because it needs to process more information per second than if your buffer size was a larger buffer size, right? So that's why when you change your buffer size and you make your buffer size smaller, that your computer may not have enough power to be able to handle that. Why you might get stuttering, right? Has anybody tried to shorten the buffer size in their DAW to as short as possible, like 64 samples or 32 samples, and then they find that they're getting breaks in their audio, and it's going because it's not able, that the CPU is not strong enough to be able to process that many samples in 1 second. But anyway, going back to prepare to play. So this is like we were saying, this is a common place where prepare to play is called. So it's normally called when the constructor is run and you're getting, and you so once everything is set up, I believe prepare to play is called once you hit the space bar to actually begin processing through the plugin, or once you hit a key, then normally somewhere in that process, prepare to play is actually called to pass on any information that any other parts of your code need to know about for sample rate and samples per block, or what I call buffer size. Okay. Any questions about that? Anybody? Okay. So, okay. Once again, a lot of this stuff is stuff that I don't really mess around with. Okay, now for the big kahuna of audio plugins, what you call the process block. So does anybody know what a process block is? Okay. Yeah, it's where the sample processing is happening. So a lot of times if you're looking at a different, if you're looking at a different framework, or if you're looking at a DSP algorithm, the function will be called process block. It'll be called get audio block process, something to that effect. And that's actually where the audio processing happens. Okay, so this is probably the most important function of your audio processing. This is where all the magic happens. Okay. Has anybody ever heard the term "don't block" on in your audio callback? Has anybody ever heard that term before? Anybody? Okay, a few people. Does anybody know what that actually means? Right. So you need to do, so you said you need to do everything fast, so you don't want to do heavy processing. Can you tell me what you mean by heavy processing?
Actually, you have a kind of a processing block that needs to take longer than the very short time frame you get. So if you kind of block this whole process, because this audio callback function is called in a very fast rate.
Yeah. So he said anything that would take a long time, or take longer than what it would take for this function to call. So the biggest thing, do you know any examples of something that could potentially block your audio callback? No. Anybody? Jordy, do you know?
Memory.
Creating memory? Yeah. So creating memory is a great example of something that you don't know how much time it would actually take for that memory to be created. And because of that, when you're creating memory in your audio callback, it would be doing it at a very fast rate. Once again, whatever samples, whatever your sample rate divided by your buffer size is, that's how many times this process block is running per second. So you would be creating memory, at 44,100 divided by whatever your buffer size is times per second. And that the time that it takes to create that memory is what we call indeterminate. We don't know how long that would actually take. Another thing that we commonly as audio developers like to do within the process block, that's okay to do, like if you're just prototyping and just want to inspect what's happening in your process block, is doing a console printing to your console. So you want to see, for example, you want to print to your console to see what type of values are coming into your audio buffer, to make sure that they're within the right range, right? Does anybody know what the right range is, by the way? Right range for if you're doing audio, what type of values would you expect to be in your audio buffer? Does anybody know? Milliseconds? No, not quite. Okay. What type of values? So let's say that I'm taking my audio buffer and I'm printing out the values that are within the buffer. Anybody know what sort of values I might expect, what the range of those might be? 1 and -1, exactly. So you think of a sine wave, right? So when you open your DAW, you bring an audio file into your computer, and you look at it, and it's this wave, and it's this, and this is something that took me, it's something that's very intuitive, but it actually took me a little bit of time to make that connection, and it kind of gave me a little bit of a revelation when I was able to make this connection between what the audio buffer is and what you actually see on a screen as a music producer in a DAW, which is that when you look at an audio file or a piece of audio in your DAW, that is, as you were saying, those are values between +1 and -1, right? And do you know what those are about? Why they're between +1 and -1? Does anybody understand? Does anybody have any ideas why that might be the case? Anybody? Okay. Those are actual literal instructions to your speaker cone of how to move forward or backwards. Okay. And 1 and -1 are the maximum range that your speaker cone can move forward or move backwards. Okay. So when you look at an audio file, what you're doing is you're actually looking at the instructions of how the speaker cone needs to vibrate. Okay, it's actually the vibration of the speaker cone, and the range of those values is between +1 and -1. So that's why when it's above 1 or below -1, that's why you actually get distortion, because it's actually trying to take the speaker cone, trying to move it past where it's supposed to go. That's why it produces that irritating sound. Okay. Any questions? Any questions on that? Okay. So looking through here, looking in the audio process block, you have this node to normals. I won't really go into what that is, because that's or maybe I can talk about that a little bit. What that is when your computer is trying to process very small floating point numbers, there's a point that it gets towards where the computer actually spikes. The processing actually spikes. My understanding, my very layperson's understanding of what node to normals is that it actually just rounds out those very, very, very small floating point numbers to 0. Because if you didn't have that in there, then it would take those floating point numbers and it would actually spike the CPU. Okay. So then you have these total number of input channels, total number of output channels. Those are your input and output channels, right? So if you're in stereo, you would have how many channels? 2, right? Exactly. Then there's this code, which is once again well commented. In case we have more outputs than inputs, this code clears any output channels that didn't contain any input data. Okay, because the buffer, if you don't actually initialize it and give it values, then the audio buffer has random values in there. Okay, you don't want random values going into your output. You want the range of those values to be between +1 and -1. Okay, so I'll just erase this comment to clear, make the code a little bit cleaner. And then this is where you actually do your audio processing. Okay, so you have this for loop that goes between channels, and then normally in here you have another for loop. So I'll just write that. I'll write that now. So for int sample equals 0, the sample is less than, does anybody know what I need to write in here? So if we look at the outer for loop, we have channels is equal to 0, channel is less than total num input channels. So in this case, we're operating in a stereo environment, which means we have 2 channels. Okay, channel what? What's the first channel number? 0, right? So a lot of people think it's going to be going between 1 and 2, but in C++ and most programming languages, we start with 0. So that means that channel would start at 0, and it just goes 0, 1, 0, 1, right? And then you have ++ channel. And then we have this, which I'll talk about later. And now we go through, now what we're going to do is we're going to go through the samples. So a lot of times when audio developers are starting out, they're thinking about, they think of a buffer as just one line of samples, okay? But in actuality, it's 2, if we're working in stereo environment, it's 2 channels, okay? So it's a 2D vector, right? So each one of those is sample is buffer size number of samples. So if you had a 256 sample buffer, that means that you have 2 channels of 256 values each. So what it's doing is it's going through the first channel, looking through those samples, then it's going through the second channel and looking through those samples, and then doing something to each one of those samples. Okay. So here, what I'm going to put is buffer get num samples. Okay, so that's the number of samples in your buffer. With ++ sample. And then you're going to say do something. Okay, let me just look through here and see what we have any questions. I love it. MIDI error, this guy named MIDI error. The MIDI error is actually, if it's the same MIDI error, he's actually a legendary developer. Do you know, is anybody familiar with the Razor synth by Native Instruments? Yeah, it's like a pretty big synth. If it's the same person, it's the person who created the Razor synth. But he says that I need to work on my presentation and audience interaction skills. So thank you. I'll work on that. Thank you for the feedback. So that's where you're going to handle the audio processing and actually do something to your audio. So in this situation, we're going through each one of the channels. We're going through all of the samples within that channel, and we're going to try to do something to that. Okay. Any questions? Any questions from anybody about that?
There's just another question on YouTube that just popped in. Well, for loops.
Okay. So a for loop means it stops once it reaches the end, right? No. So a for loop literally is what it says. It's a loop. So once you've got to, so essentially you'll go channel 0. So if we're looking at line 149, it would be, it would start with channel 0 and then sample 0. Then it would go channel what? What would be next? Anybody? So it's just ran through this the first time. The first time it's run through this is channel 0, sample 0. Next time it is what? Channel 0, sample 1. Exactly. Channel 0, sample 1. Okay. Then it would do that until it hit whatever buffer size get num samples is, -1. Okay, because we're starting at 0. -1. Okay. Then, okay. So now it's run through channel 0, samples through to 0. Let's say it's 256 size buffer. So it would go from 0 to 250. Anybody know? So what's that? 255, right? Not 256 because we're starting with 0. Okay. Then what happens next? Okay, so it's just ran through channel 0, sample number 255. Now what happens? Goes to channel 1. Exactly. So now we're going to channel 1, sample 0. And then channel 1, sample 1. To the same sort of thing. Buffer.get num samples -1. Okay, now you get to the end of that. And now what happens? Okay. What do you mean by it does it again? Right. So it actually comes out of the, so now it's done what it needs. It's done the work that it needs to do for this audio callback. And it actually exits because it's done everything that it needs to do. And so now it continues on, does anything else it needs to do in the audio process block, and it exits the audio process block. Then the next time that it comes back into the audio process block, it does all this stuff that it needs to do, goes into channel, and it does all of this again. Okay, so it basically does all of the work for all of the samples in each one of the channels, and then it exits. Okay. Any questions about that? Anybody? Okay.
There's another interesting C++ question.
Okay. So what would happen if the plus was after channel? So they're looking at this, and they're looking at plus channel. Some of you may be used to seeing it as channel plus or sample plus. So this is, I'm trying to remember the technical name for this. Is this prescript, or it's pre and post something? I can't remember what the name is. So there are situations where that would actually change the behavior. In this particular situation, that wouldn't change the way that this happens. Okay. So so the answer to this question is that it wouldn't change the behavior. Okay. Okay. So Going down a little bit further, we have, so you have this has editor function, and it returns true. So says changes to false if you don't want to supply an editor. So that means that, so sometimes for whatever reason it may be, the creator of the plugin doesn't want to supply a user interface, or maybe they want to run some algorithms and be able to do processes from the command line itself. So you can set it up where you can actually do that. And so if you did that, you could change this to false and say, okay, I don't need an editor. And then you have this interesting function called create editor. Okay, so in this, can anybody tell me what this is? Okay. So it says return new Queen Mary plugin audio processor editor. This. Okay. Does anybody know what that actually does? Anybody? Okay. It's a little bit of a trick question because I don't think I've given you quite enough information to be able to really answer that question. So the answer is that you have the plugin editor, and the name of that is Queen Mary plugin audio processor editor. Okay. And what it does here is it creates a new instance of the editor. So it's actually this plugin processor that actually kind of kicks everything off, and actually where it actually creates the UI. It creates an instance of the user interface. Okay. A little bit later, what we'll do is we'll JUCE supplies this this nice little tool called the generic audio processor editor, which is a way that it will generate an editor for you without you needing to create a user interface yourself. But we'll do that a little bit later. Okay. Then you have get state information, set state information. Okay, that's saving and loading. Okay. Does anybody know what XML is? Okay. What's XML? Yeah, extensive extended markup language. And what's that? Yeah. Right, exactly. So it's the way that we're able to store information. So going back to that username and password example, that you would have, maybe if you had that in XML, it would say something like username, and then you have a bunch of usernames, right? Then you have a bunch of passwords. Hopefully somebody intelligent wouldn't put all the passwords in an XML, but that's just an example. So if you had a parameter, like let's say filter, so if you were making a filter, one parameter might be filter cutoff, right? And that you're in your DAW project and you change your filter cutoff, and now you want it to save. So an example of how that might look in XML might be parameter equals filter cutoff, value equals 500 hertz, and then it saves. And then what you do is that at a later point when you reload your project, what it does is it reads from that XML and it says, okay, they saved the filter cutoff to 500 hertz. Now I just need to restore that. So this is a way to save the state when you when you're saving your project, closing your project, and restoring your project when you're opening it back up. Great. So that's essentially it for the plugin processor. Does anybody have any questions? questions about the plugin processor? Okay. All right. So let's move on to the plugin editor then. Okay. So your plugin editor is, actually I should have done this with the processor as well, but I won't really worry about it, is that if we look at the class, we see that we have this line of code that says public JUCE audio processor editor. Does anybody know what that means? Okay, so you have class, then 1:, then public JUCE audio processor editor. Okay, I'll give you a clue. It's called inheritance. Does anybody know what inheritance is? Yeah, so it has access. I wouldn't say to all. So she said to all methods, but sometimes a class has private methods that you can't access, but it essentially gives you functionality, right? So like what you were saying, it essentially takes something. So it takes this object that you're creating, this idea that you're creating, and it says that what I'm creating is a type of audio processor editor, right? So, if we take another example, for example, let's talk about a car, right? So if we were saying a car, it may have a color, it may have 4 wheels, but we have different types of cars, right? We might have different maximum speeds. We might have different types of tires. We might have different colors for the car. Okay, so what we could do if we had a car class is that we would be able to create our own car. Maybe with that car, we would want to give that car a certain color, a certain max speed, and describe that car closer. But it's essentially like a template. It's like a factory. And that's what we're doing here, is that we have this audio processor editor. And one nice thing that you can do is if you're in Xcode, you could you can do this in Visual Studio or whatever IDE you're in, has different commands to be able to do this, but you can do this jump to function. And what you do is that'll actually bring you into the audio processor editor class itself. So you can actually see how it works. And for anybody that is looking to learn more about C++ and learning how C++ actually works and how to write good C++ code, just have a look at the JUCE code base, because it's probably one of the best code bases to take a look at to really get an idea of how code is well written, well documented. They've really done an amazing job with this. So in here, it's its own class, right? And so you have these protected methods, which I won't get into, but you have all of these. So you have these public methods. So as she was saying, there are these different methods that you're able to call. So things like get audio processor. Okay, so as we were saying, the processor in plugin processor that actually creates an editor. But when you want to access parameters or certain things that you may need from the plugin processor, the way that you can do that is you can access it to, where did I go? Back through here. The way that you can access it, you can actually access the audio processor through this get audio processor. And what that does is that returns the processor. So if you have, once again, filter cutoff parameter that you've created in your audio processor, you can actually, if you make that filter cutoff parameter public or accessible, then what you can do is you can say processor dot filter cutoff, right? So that's the way that you actually modify that parameter. Okay, just to give you an idea of things to come. Okay. So now you have the constructor, okay, and the destructor. Then you have these paint and resized functions, okay, and they're and it says this word override. Does anybody know what override means? Okay. Right. Yeah. So if you want to re-implement the function, then what you can do is you can create your own version of the function, okay, which is called a virtual method. So if we go down here to paint, let me find paint. Oh, I don't actually see it. Oh, is it because, 1 second. Oh, it's because it's a component class. So this is where, an audio processor editor is actually inheriting from another class. So sometimes this is a great example of a situation where you say, oh, I've gone into audio processor editor, I've looked for this paint function to see what I need to do with it or how it works, but I don't see it. But then you see, oh, audio processor editor inherits itself from another class called component. Okay, so component is a class that is essentially any visual element in JUCE is a component. Okay, so and we can see that inherits further functionality from mouse listener, which we won't get into, but here we should see the paint function. So, okay. And in here, you actually see the documentation. Components can override this method to draw their content. Okay, so that's exactly what you were saying about you can take this, and it goes back to the car example where, okay, I have this visual element, this user interface, and let's say I just want to paint the background a certain color. That's where you would say define that, and that's where you would define that. So you see that this is a virtual method because it says virtual, and they have what's called virtual methods, and they have what's called a pure virtual method. Does anybody know what that is or what the difference is? Okay, anybody? No? Jordy?
Does virtual allow you to override it, and pure virtual means that it's an abstract class you need to override it?
Exactly. So a virtual function means that it's optional. So you can choose to do your own implementation of paint if you want, but you don't need to. Okay. So a pure virtual method is where to use the class, you actually need to implement the function yourself. Okay, and this starts getting a little bit further into C++ and names of and C++ terminology, but that makes the class what's called an abstract class. Okay, abstract class means a class that has at least one pure virtual method. Okay, so a little bit of word salad for you there. And plug-in processor is a great example of an abstract class. So if we go to, if I go here into the audio processor, and you can tell what a pure virtual function is when it has this little equals 0 at the end. Okay, so that'll give you a clue as you work through working with C++. And let's say that I was implementing a new audio processor and I didn't do everything properly. You would probably get an error that says, Queen Mary or audio processor is an abstract class. That means that there's a pure virtual method that you need to write your own implementation for that you haven't done yet. Okay, so we can see this example, and sometimes it can get it can get a little bit tricky in terms of thinking like, okay, what does it actually want me to do? What does it actually want me to do here once I've implemented the function? So here it says get name equals 0, and you can see that so this is a template, right? This is something that JUCE kind of created for us, but we can see that what it did is where is it? Get name. We can see that that's been implemented there. Get name. Okay, that's why we have that override keyword to let it know, hey, it's a virtual method that we've provided our own implementation for. And in this situation, it returns this JUCE plugin name. Okay, so typically a pure virtual method is for something that we need to. There's something that is essential for the class to work in order for basically it's useless without doing some sort of implementation of the class. Okay, but that's not the case for plugin editor. It doesn't really have any pure virtual methods like that. So what it's done is that it has these two methods, paint and resized, that we can do, and I'll describe what those are here shortly. So once again, we have this the constructor. Okay, we know it's a constructor because it says it has the same name of the class as, so it just says Queen Mary Audio Processor Editor, Queen Mary Audio Processor Editor. That's how you know it's a constructor. Okay, and we know that it's a function. It's something that happens just once when the class is instantiated. So it's this set size function. So that's your background. That's your background canvas, and it set it to a size of 400 by 300 pixels.
Sorry, what's the difference between a function and method?
There is a slight difference, but I think probably 95% of people use those words interchangeably, and I use them interchangeably myself as well. But if you get really technical, there is a very slight difference, which I can't remember off the top of my head. I read about it once way back when, but most people in layperson's terms, they use those terms. But I think technically you would say, if you got really technical, you would say a function, but you could call it a method and everybody would know what you're talking about. A great question. So once again, destructor, we know it's the destructor because it has this tilde here. And then we have this paint method. So paint is where we do our painting. It's where whatever we want for this component, whatever color that we want this component to be. In this case, it's setting it to some sort of default color, and it's giving some text that says "Hello World." Okay, so that's what it's doing there. Then you have this function that's called resized. Okay, so the thing about a component is that it's like a tree. Okay, and what I mean by it's like a tree is that a component can hold other components inside of it. Okay, so in this case, what we'll do a little bit later is that we will have this this editor component, which is kind of our background. And then on top of that, we will place other, well, we'll just probably have time to do one, but what you would do is you would place all of your what they call child components underneath of it. Okay, so it's a hierarchy that if you have certain things that you're doing in the parent component, that should populate down to the child component. So what you can do is that this is like the top of the tree, your parent component, and then within that, you're creating other components, sliders, UI components, text, things like that, that will be your children components. And then you have this resize method, which is where you actually define how you want those components to be drawn. Okay, so if you want it to be at the top left of the screen, so let's say you draw a dial, you want it to be at the top left of the screen, you want it to be in the middle of the screen, that the resize method is where you would actually do that. Okay, and they have different ways that you can actually draw your plugin code. Okay. Any questions? Any questions? Anybody? Not anything I've discussed so far? Okay. I think this is a good natural time to take a short break. I know you've been in here for nearly 2 hours now. And what we'll do is when we come back, we will actually start building our own plugin. Okay. So maybe, yeah. Oh, fantastic. Oh, one question. Go ahead. What's that? The plugin is going to be what we call the hello world of plugins, which is going to be a gain dial. So that means we're going to create a gain parameter, something that controls the gain of the plugin. We'll create a UI element, which will be a dial, and then we need to connect those two together. And that's what we're going to do.
Perfect. So should we say 30 minutes for lunch?
Yeah, so we'll be back in 30 minutes. And we'll start with part 2, which is actually creating your first plugin. So for everybody online, hope you join us in 30 minutes. Great.
unmuted.
Okay. All right, we're going to get started in just a moment, just waiting for some people to come back and join us. But we're actually going to get started with writing some code. Finally. Woohoo! Should I just go ahead and get started? Okay. Maybe I'll just give one. Just remind them because I don't want them. I don't want them to miss this critical step. But they'll be like, "What is going on?" To save your JUCE project, you mean? Oh, it'll automatically save. Yeah, so it automatically saves the code as you write it. But I think that there's an option in JUCE just to hit save, I think. So if you hit file, if you hit save or save all, you'll be. I've never had to worry about it now. Yeah, so that should be fine. Yeah, so I will that. Right, now we get into the fun stuff. Okay, everybody know that they're, okay. All right. I guess we'll get started. So, for this part of the workshop, we're actually going to start writing our first plugin. So this first plugin is a very famous one. I've done it loads of times. It's the most simple example of writing a plugin that I think I can think of, which is creating a single parameter plugin and being able to load it in your VST, and it's going to be a game plugin. Okay, so what it's going to do is it's nice because it's very intuitive to understand once I explain it, how it works, and to get you set up with a basic framework of what you would need to do in order to start creating any plugin. And you can see multiple ways that this can extend out. So the first thing that we want to do when we create a plugin is we want to think about what sort of parameters that we want the user to be able to change. Okay, so in this particular example, we're creating a game plugin. So naturally, we want one parameter where the user is going to be able to change the gain. Okay, to be able to change how loud the audio, the incoming audio actually is. So in order to start creating parameters in JUCE, there's a little bit of code scaffolding that we need to be able to set up. It gets a little bit complex if you don't have a lot of C++ under your belt, but I'll do my best to explain it along the way. So the first thing that I'll do is the way that parameters are mapped out in JUCE is typically using what's called, it's a very long name. It's called the audio processor value tree state. Okay, it's a very long name. essentially what it is almost like a fancy XML, as we were describing before. So where we declare a parameter, we tell the parameter what type of range that we want it to be. In this case, we'll start off with a game parameter. The minimum value will be 0.0. The maximum value will be 1.0. And it'll be a parameter, and the parameter is just going to be called game. Okay. And so we need to create a audio processor value tree state. I also need to create this some code scaffolding for being able to create parameters and put them inside this tree. Okay, so it's a little bit complicated, but just follow along. So, and feel free to ask questions along the way as well. So another thing that so the way that this is defined in JUCE is that we have what's called a parameter layout, which is a set of all of our parameters. Okay, and so if you go into the JUCE documentation and you click on parameter layout, it's a little bit, as I said, if you're just starting out, this could look a little bit daunting, but I'll explain it to you the best that I can. And we can see that the parameter layout holds some unique pointers to these things that are generically called items. And items are actually just our parameters. Okay, so they're unique pointers to items. Okay, so in essence, what we're going to do is we're going to create all of these parameters. We're going to put them inside this data structure called a parameter layout, and that's going to be our set of parameters. Okay, so the way that we do this is so one thing that one thing that I want to do here before I start here, because I think that there are some there's a little bit of cumbersome code that I need to do before I'm actually able to build this. So up here at the very top or somewhere in your IDE, there will be a way that you're able to change what's called your target. Okay, so a target is so let's say that you have this code that you have this code and you want to build it. Okay, currently the way that we think of building the way that we think of it is we just say, okay, we write this code, we want to build all of it. Okay, but over time what you find is that you may write this massive code base, and that there may be certain things that you may want to build, or you may want to build all of it, or you may just want to build a library, and you may not just want to build all of it at once. So an example of how this may work in this plugin example that I'm talking about now is maybe I just want to build the VST3, or maybe I just want to build the AU version of the plugin. And so what I could do is I can actually go up here to the targets, and I can actually define what I want to actually build. And I believe what we'll find is if I build this, that we will actually annoyingly get an error. And if we don't, that's fantastic. So what I'm doing is I'm trying to build all versions right now. Right? Oh, it actually succeeded. There's this warning, this link time optimization warning that you may see. Don't worry about that. I won't take you through maybe at the end I'll show you how to fix that, because there's just there's a linker command that we need to give in order to get rid of that. Let me just try to build the AU version, make sure that builds. Oh, that actually succeeded as well. So that's awesome. Okay, so that's good. So far everything is. Let me try the standalone. Let's see if the standalone works. Okay, that says that succeeded as well. Let's see if the standalone plugin will actually show. Okay, so this is our plugin so far. Just blank screen, says hello world. Okay. So now let's just say that I want to get rid of that. That I want to get rid of the hello world, and I want to change the color of the background. What I could do is I could just go here to the paint method, and we see that we have this g.fill_all, which is just fills the background with a color. Okay, what I could do is I could just take all of this stuff, and I could just say JUCE colors black. Okay, so now when I recompile it, it should just show up as black. So there we go. Now I just want to get rid of all that hello world text. And now I've done that. Okay, so if I recompile it, once again, you can see that the target that I'm building is the standalone plugin version. And that just enables, of course, I'm not going to be able to run any audio through it because it's a standalone version, but it's just for me to visually see what's happening. So that's just to show you, just to make sure that the plugin is actually building and just do some basic things. Okay, now going back to the plugin processor and to the parameter layout. Yes. Okay, zoom in on this.
Maybe even just in the, on this, but more specifically in the code.
In the code?
Yeah,
Yep.
if possible, when you're in the section.
Yeah, how is that?
I think that would be better.
Yeah. Great. Let me turn on my live chat so I can see. Great. Okay. All right. So now we need to generate a parameter layout, okay, which is our container for all of our parameters. Okay. So what I'm going to do is I'm going to create a function where I'm able to list the names of my parameters and create a parameter layout. Okay, the way that I'm going to do that is by creating this function. So you know about, does everybody know about return types? Okay, so if we have a function, we see that we have this void, we see that we have this get current program, it returns an int, get tail seconds returns a double, right? So everybody knows about what return types are, right? Okay, anybody that's done any type of coding will probably know about that. For this particular function, we want to create an audio processor value tree state parameter layout. That's what we want to create and return. Okay, so that's how I'm going to start this. So I'm going to say JUCE because this is a JUCE function. Audio processor value tree state. This starts getting a little bit long. And then : parameter layout. Okay, so that's the actual return type. That's what I'm actually returning. Okay, and I know that looks a little bit long and daunting, but that's essentially what it is. And then I'm going to call this function create parameters or create params, and then the braces at the end. Okay, so does anybody have any questions in terms of what that is or why I'm doing that? Okay, I know it's a little bit to wrap your head around to start off with. Okay, so that's actually a function, and I'm going to implement the function very shortly, but I'm just declaring it in this header file. Okay, anybody? Don't be scared. Okay. So now I'm going to create this function. So once again, the type of object I'm returning is a JUCE audio processor value tree state parameter layout. Okay. Now, the part that if you're just getting started with C++, a part that commonly trips people up and used to trip me up a lot is that I would just write it the same way that I would declare it here and just say create params or params. And then, but one thing that you're missing is you need to let your C++ file know that the create params function that you're trying to implement is the one that's here in this class called Queen Mary plugin audio processor. Okay. So if I just leave it blank like this is what's called a free function, which is something different. Okay. I actually want it to be referring to the create params function that I've created within this class. And you can tell because if you look at just about any other function, except for the one above it, you'll see that it says void Queen Mary plugin audio processor : set state information, void, then the class name, and that's what's called a fully qualified class name. Okay, so that's why what I need to do is it actually needs to look like this. Okay. JUCE audio processor value tree state parameter layout, then space queen, then the class name, then create params. Okay, not very beginner friendly, but that's essentially what it is. Okay. Does anybody have any questions about that or having any issues with that? Anybody? Yeah, go ahead. Right. Yeah, exactly. That's correct. Yes, that's actually the return type. One way that you can actually shorten that for yourself or to make it a little bit more legible is you can do what's called a using statement. So like the code word, the keyword using is, okay, I want one word to replace this whole mess of words. Okay, so this could be useful as well. So if I say using parameter layout, so it can't be something that's already made. It's something it's a name that you got to make up yourself. And I could say using parameter layout equals all of this. Okay. And then what I can do is I can just call this parameter layout like that. Okay. And that actually cleans it up a lot there. Okay. So I'm just basically saying parameter, when I'm talking about parameter layout, I'm actually talking about this JUCE audio processor value tree state parameter layout. Okay. Now another thing is that this using statement is only applies to the scope of that you're currently in. So that doesn't actually carry over, unfortunately, to this part. So if I just say parameter layout here, it actually won't know what I'm talking about. See how it's not popping up for me? But what I can do here is the same thing. Okay, and I'll just put a little divider line in there. Okay, so that just makes it a little bit more legible there. Okay. Any questions about what I've done there? Anybody? Okay, cool. So now I actually have some code notes, so I'm gonna refer a little bit to those if I need to. And so the first thing that I'm gonna do, you see that we have this warning, non-void function does not return a value. So it can be very easy to get intimidated or to get daunted or just throw up your hands and say, I don't know what that, I have no idea what that is, okay? But my first piece of advice with that is just try to relax and take in what it's actually saying, because a lot of times if you can actually just read it word for word, it'll make sense and it'll actually tell you what you'll actually be able to understand what it's trying to relay to you. Non-void function, okay? So what's a non-void function? So it's a function that is not void, okay? So in this case, it's not trying to return void, it's trying to return a parameter layout, okay? Non-void function does not return a value. So it's expecting to return a parameter layout, but it's not returning anything. So that's why you're getting that warning, because it's expecting for you to say, return my parameters, return my parameter layout. Okay, so now what I could say is, what I'm going to do is I'm going to create a parameter layout object inside here. Parameter layout, I'll just call it my params. Okay, and then down here, what I could say is return my params. Okay, now that warning disappears because now it's saying, okay, I'm good. I know it's returning a parameter layout, and now I'm happy now. Okay. Any questions about what I've done there? Anybody? No. Okay, great. So now what we need to do is we need to create a parameter in here. Okay. So once again, a lot of times what we can do as audio developers or as developers in general is we can just look at what the instructions say and say, I can't make sense of that. I don't know what that means. A class to contain a set of ranged audio parameters and audio processor parameter groups containing ranged audio parameters. Okay, I'm just trying to help you develop this muscle of like how to start thinking about these things, or how to start like working your way through these things, because there are so many things in audio software development that are like, okay, I need a parameter layout. Okay, what's a parameter layout? It's ranged audio parameters. I don't know what ranged audio parameters in. And so you get into this like nested, I guess I could call it like a nested knowledge space, where it's like, okay, well, in order to know about a parameter layout, you need to know about ranged audio parameters. In order to know about ranged audio parameters, you need to know about audio parameter float. And so you get this nested thing where you have to kind of go down this tree of knowledge, learn about one thing, learn about the next thing, and then that'll bring you back to the first thing that you were actually intended to do. Okay, so here we have this a class to contain a set of ranged audio parameters. So let's say I don't know what a ranged audio parameter is. Okay, so then I go back to my documentation, and now I search for ranged audio parameter. Okay, now we see that we have this ranged audio parameter class. Okay, and now it says this abstract base class is used by some by some audio processor parameter helper classes. So you're getting a couple different words in there now. Audio processor parameter, ranged audio parameter, and now you have some other things, audio parameter bool. And if you look at this, so this is what's called an inheritance diagram. And now it's showing, okay, ranged audio parameter, that there are several types of ranged audio parameters. Okay, you can have an audio parameter bool, okay, so true or false. Audio parameter choice, 1, 2, 3. Audio parameter float, or an audio parameter int, okay? So since this is a gain parameter that we want to create that's going between 0.0 and 1.0, what do you think that we want to create here? Any ideas? Okay, so our parameter, we want it to go between 0.0 and 1.0. Any ideas? We've got audio parameter bool, choice, float, or int. Float, yes, very good, because it's going between 0.0 and 1.0. Okay. So now one little wrinkle or one little trick that you just kind of have to know is, so let's start with, so let's go down in here, and you see that there's this add method, and it says stood unique pointer items. Okay, so this items, we want it to be a ranged audio parameter or a type of ranged audio parameter. And that's really what it's referring to. Okay, so this is what's called a templated class. And templated classes can be a little bit tricky, because what can happen is that you get this you can get this word that comes into play here, like items or type, that's just a very abstract concept. And so until you read through the documentation, you don't actually, it can be difficult to understand what it is that you're supposed to put in there. Okay, so but in this case, it's a type of ranged audio parameter. Okay, so what I could do is, once again, we have this my params.add, and it says that it wants a stood unique pointer of items. Okay, there are some of these things, like I said, you just learn them through experience. You just learn them through figuring your way through something, or looking at somebody else's documentation or how they did it, and then you realize it when you come in to do it the next time. So let's say that for this one, I say, okay, it wants a stood unique pointer. I'm going to say stood unique pointer, and we once again want a audio parameter float. Okay, so this is a JUCE audio parameter float. Okay, so now we're at this point. Okay, this is what we have, but what we need to do is we now need to look at audio parameter floats. Okay, and what that documentation is. So I'm going to right click on this and open a new tab. Now we have audio parameter float, and what I need to do is read through this documentation and figure out, how do I create an audio parameter float? Okay, so reading through it, a subclass of audio processor parameter that provides an easy way to create a parameter which maps onto a given normalizable range. Okay, I'm not going to worry about that onto a given normalizable range. That's just a distraction that we don't need to deal with right now. Okay. The unfortunate thing about some of these is that to do something simple like this, it actually kind of throws you into some C++ that can be quite daunting for somebody who's just getting started out. But follow along, and I promise you it'll be okay. Okay, so here as you can see, there are 3 constructors, okay? So 1, 2, 3. We know that they're constructors. How do we know that they're constructors, first of all? Anybody know? Go ahead. Right, because it has the same name as the class, right? Yeah. So the class is called audio parameter float. And so when you see this thing that has the same name as the class name, we know that that's a constructor. So these are different ways that we can actually create an audio parameter float. And it needs to know certain things or have certain pieces of data piped into it to create one. Okay, so there are these different ones. I'm going to go to the most simple one. Okay, so it takes something called a parameter ID. Okay, takes a string. I imagine everybody here knows what a string is. It's just a line of text, and it's going to be a parameter name, the float minimum value, the float maximum value, and a default value. Okay, so now the only part of this that I don't know is a parameter ID. What is that? So now I'm going to open that. And it says combines a parameter ID and a version hint. Unfortunately, it doesn't really give you much more information than that, which I think is unfortunate. But a version hint, I actually looked into this, is let's say that you create a version of your plugin, and then let's say that you decide to create a 2.0 of the plugin that has some additional parameters. The version hint is something that you could provide to say, okay, if the person is using version 1 of this plugin, provide them with these parameters. If it's the 2.0 version, then you can give them these other new parameters. Okay. Another thing here about parameter ID is that sometimes in these arguments you see this equals 0 or equals something. That lets you know that that's an optional argument right there. Okay, so we don't actually even need to provide anything there if we don't want to. Okay, but if we wanted to say it's version 1, we could say it's version 1. But otherwise, it just wants a string, string-like. They should have just called it an identifier. Okay, it's just what we want to call the parameter. Okay, so now we know what a parameter ID is. And now we go back here, we say, okay, now I know what I need to do to create a audio parameter float. I'm just going to copy this, and I'm just going to throw that into here like this. Okay, once again, you get a bunch of red because it's just saying, I've just pasted this in here. But let's just go through that step by step. Okay, step 1, parameter ID. Okay, I need to create a parameter ID. So it just, in this case, I'm not going to worry about version hint unless I need to, but I'm just going to give it this string that's going to be called identifier. So identifier is just what do I want the parameter to be called. So I'm going to create a JUCE parameter ID. And is there any one of these? I'll just do it like this. And the string name, we will call it gain, like that. Okay, now I've just created a parameter ID. That's it. Okay. Now we got the parameter name. And normally what I do is I will call this the same thing, but just with first letter is capitalized, subsequent letters are lowercase. Okay, and you can reverse these if you want. The minimum value is what? Does anybody know what minimum value we want for this? 0, or better yet, 0.0, okay? Now what I'm going to do is I'm going to put an F, a small letter F. Does anybody know what that means? Float, exactly. So that just lets it know 0.0, and I want this to be a float. Okay, so it's like a little kind of cast. I don't know if cast is really the technical word that would be used there, but it denotes it that it's supposed to be a float value and not a double. Okay, because 0.0 could be a float or a double. Okay. Maximum value is 1 or 1.0 F. Okay. And we will give it a default value of 0.5. Okay. Okay. And now we get an error. Okay. And it says no matching constructor for initialization of stood unique pointer audio parameter float. Okay. And this is a little bit tricky because it can lead you down in the wrong direction. But the reason that, or if hopefully my intuition is right and I've done everything properly, the reason that we're actually getting this is because you put in the arguments when you actually are allocating the memory. Okay, so are people familiar with unique pointer and make unique? Anybody else? Probably not. Okay, so this goes to another part of the conversation, which is that there are loads of C++ tutorials on pointers and unique pointers and shared pointers, but there are barely any tutorials about why you would use a pointer or what pointers are used for or what case that you would use a pointer. Does anybody know or have any ideas on situations where you use a pointer or why you would want to use a pointer rather than just a regular parameter? Anybody? Yeah, go ahead. Okay. Okay, so saving, you said saving memory? Yeah, so saving memory is definitely part of the equation, because what a pointer can do is it creates memory. So what it's doing is it's looking to create a piece of memory where it stores all of this information, such as the gain, the parameter ID, the gain, and the minimum maximum value, default value, and it stores this in the memory space. Okay, and once that goes what they call out of scope, then it can clear that up. Okay, so that's one thing, is that especially if you have like a very large object. Let's say that you're playing let's say that you're creating a game and that you have a scene, right? So some big high resolution majestic scene that has trees, has mountains, has all of these graphic assets that you need to load. Well, once the game is over and you go to a game over scene, you don't need all of that anymore. And so you want to clear all of that away. And, because it's heavy and it's big, right? So that would be an ideal situation where you may want to use a pointer, because then what the pointer can do is on the fly. By on the fly, what I mean is so it's not compilation time. So what I mean by compilation time means when I hit the button and it's just like loading it's just like kind of loading everything, right? And then you have what's called runtime, which means I'm actually inside the game, I'm actually using the plugin, and now I want to create something on the fly, but it's something that will be temporary, and then I just want to get rid of it at a later point, and I don't need it anymore. Okay, so that's a good use case for a pointer, something that needs to happen during runtime or not immediately when I'm building the plugin. Okay, So this needs to be a, and so you have two parts to creating a pointer, which are declaring it, saying, hey, I have a pointer, I have a pointer that I may want to use at a later point. Maybe it's this game scene, maybe it's this parameter. And then you have this other part to it, which is that, okay, now I'm actually going to allocate memory. Now I'm actually going to, I've declared it, and now I'm going to initialize it and actually allocate memory for it, okay? And the reason that we're getting this error is because when you say stood unique pointer, that's actually a declaration that you're going to create something called, that you're going to create some sort of audio parameter float, okay? When you actually allocate it and give it these arguments, okay, the constructor arguments that we were talking about earlier, that actually needs to happen during the allocation stage, which is this other function, which is called make unique. UNIQUE, okay, which is like this, and that should fix. So that should fix us, okay. So to break that down into individual steps, because what it's done is it's kind of declared it and created it at once. But one thing that you could do just to show you what that looks like broken down into individual steps is you could say stood unique pointer, and then this is a JUCE audio parameter float, and I get rid of all this stuff, and then I just give it a name. I'll call it game param. Okay. And now what I could do is I can actually allocate this in a separate step, okay? So in this particular scenario, I'm doing this like right underneath of it. But I could actually do, but now I do this. Game param equals this. And now, so that's actually, and now I think we're good. This is going to give me problems. But yeah, so that is initialization or declaration and then initialization. Okay. But in this, and I think that I could actually do this now. I could just say game param like that if I wanted to. Oh, and that's not going to work though. This actually needs to be declared inside of it. Okay. So, but that's just to show you kind of what's happening there and give you a small lesson on creating a unique pointer. Okay. The reason that it needs to be created inside of this parameter layout object is because that now controls the lifetime of that controls the lifetime of the of each one of these audio parameters. So when my params gets destroyed, or when it passes this to and creates a parameter layout, that when that gets destroyed, it cleanly destroys everything that's inside of it. Okay, all of the parameters that you've created. But that's how you create your first parameter. Okay. Any questions? I know that was a little bit dense. Okay. So feel free to ask any questions that you may have there. Anybody? No? Okay, cool. Okay, so now what we need to do is we need to take that game parameter and we actually need to somehow apply it to our audio buffer and use that to change the game. Okay. Okay. So going back to our for loop within our process block, we have this line that was already written to us within our template called channel data, which is buffer.getWrite pointer. Okay, so within an audio buffer, you have what's called a read pointer. Okay, which means, okay, I have this buffer, it's coming in, so this audio is coming in, it has values between -1 and +1, and I just want to read them. I just want to look at them, and I don't want to change them, but maybe I'm using it for a visualization, for level meters or something like that. Okay, and then I have what's called a write pointer. A write pointer means, okay, I want to point at each one of the objects or the values within the buffer, and I want to do something to them. Okay. So what that gives you is it gives you a pointer to channel data, and channel data is that is actually it's like a vector essentially. So that is the collection of samples or your buffer for one channel. So, and you can tell that because it says get right pointer for channels. So if channel is 0, it's saying get the right pointer for channel 0. Okay, and so channel data, it's a buffer. Okay, a vector of floats essentially. So now if I wanted to change the samples within the channel data, does anybody know how I would do that in code? Okay, so now I have channel data. Does anybody know? It's a little bit of a tricky one. Okay, so if I want to get, I'll keep it kind of open-ended. If I want to get one sample, or if I want to get all the samples in this channel data vector, how would I do that? Okay. Anybody? What's that? That's right. Yeah. Yeah, square brackets. Great. Okay. So like she was saying, channel data is like a vector or an array or a collection of all the samples in the buffer. And what do I want to put in the square brackets? Sample. Yeah, exactly. So sample is going between 0 and the buffer length. So channel data is channel 0 in the first iteration or in the first loop. It's channel data is the buffer, the entire buffer of samples for channel 0. And so now what we're doing is we're taking sample and we're going from 0 to buffer.get num samples -1, of course. And let's say that I wanted to, kind of gave you half the answer there, but let's say that I wanted to I wanted to cut the volume in half. So you have some audio that's coming in. I just want to reduce it. I want to reduce it by half. Okay, what do I want to do there? Right. Yeah. So I could actually just write channel data at sample position equals 0.5. Right? And what that's going to do is that's going to take every sample that comes into the buffer, going channel by channel and sample by sample, and it's going to multiply it by 1/2. That'll take the audio buffer and reduce it, right? It'll make it smaller. Okay? We can actually test this out. Okay. So what I'm going to show you now is this other slightly complicated part of of the plugin development process, which allows you to actually debug your plugin live in a DAW. So your plugin is running live in the DAW, and now I just want to load it, and I want to see, and I just want to see if it works essentially. Because if I hit build, right? So I can hit build, and it says build succeeded, and it came up with something, but nothing really happened. And if I want to build all plugin formats, I can just hit build again. It'll say build succeeded. But as a beginner, when I did this, I thought, where's the plugin? What do I do? What do I do now? It says succeeded, but what do I do now? The answer is actually right here in the producer. Okay, there's all this like disparate kind of knowledge that you just get to know over time, which is that if you go into the producer, pardon me, you have this place where it says VST3 binary location or AU binary location, and it has a path there. Home, home, library, audio, plugins / VST. So if I go into my folder here, into library, into audio, into plugins, into VST3, okay. Oh, see, this is one of those nuances. It's actually your user home. Okay, so that's what it means by the $ parentheses home. Once again, things that you just get to know over time. Okay, so what I actually need to do is go back to here, go to my username, the audio programmer. And like I said, there are all these little tricks. It doesn't actually show the library by default. So what you do is you actually go in your Finder, you can go to Go. And if you hit the Option key, you'll see that it changed slightly there. See how that changes? And it adds an additional item there called Library. So it's one of these things where Apple doesn't think by default that you should just have access to your library. But you click and hold Option, and you hit that library key, and now that opens that up. Audio, plugins, VST3, and now we see it there. Queen Mary plugin .vst3. Okay, so it's copied the VST3 binary to that location. Okay, because that's where most DAWs load from. Now what you could do, one thing that you could do is you can actually load your DAW. And so like I'll just load Ableton now. And in here, if everything's worked properly, we'll just wait for it to come alive. If I look at my VST3 folder, by default, the company name that it's listed under is your company. And there you see your plugin, Queen Mary. Okay. By the way, if you want to change the company name that this is under, this is actually in settings in the sprocket. And here under company name, you can just put your company name, the audio programmer. But I'll just keep it like it is for now. Okay. And now when I load this, it loads my plugin, which is just some blank window. Okay. I wish I could zoom in on the Queen Mary plugin, but if all of this is working properly, so let me just change this to the actual HDMI, which is actually not really even that important, but let me just load an audio file here. Actually, let me go back here, go to use a library. or let me just go to, just give me a sound. I'll just load one, just drag one in really quickly. Okay. So I have this wave file, or you can just use one. So now what I should see, so I have my plugin loaded, is that down here you see some it's unfortunate that it's very small, but you'll see on the left-hand side of the plugin, you'll see the input meters. And on the other side, you'll see the output meters. I'll just turn this down a little bit. And they should be what? Different, right? It should be different because because there's audio coming in, which should show what the original audio level was at. We're cutting it in half. And so what the resulting audio should be lower. Okay. And it's maybe not as obvious. Let me make it even more apparent. Wrong one. Let's make it 0.1. Okay. So now that's rebuilt. For now, I would just reload it in Ableton Live just to show you again what it looks like. I just have to create the project again because I didn't save it. It's all these little things. Okay. Take it, drag it in. Okay. Grab my plugin. Your company. Okay. Now when I play it, you can see that that's drastically different, right? Okay, can everybody see that? How that's higher there than it is here. Okay. So that lets us know that the plugin is actually working. It's actually working. It's actually doing what we want it to do. Okay. So that's pretty cool. Okay. So we got a working plugin. So now I'm going to show you how you can actually do that in one step. Rather than Ableton can have a little bit. Once again, there are all these little parts in the process that can have little like, oh, you need to know about this, or you need to know about this little edge case. So Ableton actually has a little edge case where it doesn't sometimes work in the debugger properly. But I'd recommend using Reaper. Reaper is awesome. And it's free, which is phenomenal. And it makes it super easy to do this. So in Xcode, so what I'm going to do is I'm going to set it up where when I hit build when it builds successfully, it will automatically open Reaper for me. And I can actually audition it live in real time. So it actually takes what I've just done and it kind of pops it into 1 or 2 steps. Okay. So the way that we do this is you go to Product, Scheme, then Edit Scheme. It takes you into this screen, and I wish I'll show you a video where you can actually learn how to do this in Visual Studio Code, or not Visual Studio Code, Visual Studio. So those are 2 separate things, confusingly. But I'm going to take this executable, and I'm going to hit that I want to. Right now it's set to none. I want to go to other. And now it gives me a place where I can pick an app that I want to open when my plugin builds successfully. Okay. And in this case, I want it to be Reaper. So choosing that, I hit close. And now when I hit build, you see how it just opened Reaper like that? Just opened it automatically. Okay. Now if I hit effects, now I'm caught in this. So I want to add a plugin. Okay, and there we see our plugin. And that's nice too, because it lets you know when there's new plugins, which is awesome. And this is Queen Mary. We're going to load the VST version. It'll be just a blank screen. And there it is. Okay. And now actually what I could do is I can just save this. Or actually it's already saved, but I'll just call it blah. I'll just hit save. And now what it does is when I load, when I build the plugin, I can actually just load all of that, and it'll load the project with the plugin and everything all in one step, which is really convenient. Okay. Any questions about what I've done there? Oh yes, I forgot to say, there's a, if you want to learn how to do that on Visual Studio, if you just in YouTube do Will Perkle debug, it'll take you to these videos where it'll show you how to do the same thing that I just did, but do it for Visual Studio. Okay, and I'll make a video. I'll actually make a video for that because I just got a Windows computer, so I've gone to the dark side now, and now I'm learning how to finally do Windows. Okay, any questions so far? Can you say that a little bit loud? Yeah. So Visual Studio and Visual Studio Code, I didn't name these, but they're actually two different IDEs. Okay. Yeah, you can actually use if you use CMake. If you use CMake, you can use Visual Studio Code, which is one that people really love. But with the Producer, Visual Studio Code, unfortunately, is not one of the supported IDEs. It's only Visual Studio. Yeah, it's more like a text editor. Yeah, exactly. So that's another thing, is that you can get, when people say IDE, that can mean a lot of different things. So like, and this is something that I've actually learned recently myself, which is that Xcode and specifically Xcode and Visual Studio are actually kind of bundled, like more of like a bundle of like where you can change settings, you can it has a compiler that's closely coupled with it. Whereas other ones, like if you look at what's it called, Sublime Text, they're more text editors than IDEs. IDEs are meant to be like kind of this comprehensive all-in-one package that does all of these different things for you. Changes header search paths and all of these different things. Okay. Any other questions? No? Okay. What do we think the next step is? Anybody got an idea of what the next step should be? Okay. What's that? Right. Make the gain user controllable. Right. So one thing that we want to do here is we need to figure out, okay, we have this parameter. It's called gain. We created it. It's between 0.0 and 1.0. We want the user to be able to, now we need this 0.1 to be replaced with whatever the value of gain is, right? So what I could do, I need to find a way to actually get this parameter out of this parameter layout, okay? So what I need to do, like I said, is the way that JUCE does this is using what's called an audio processor value tree state, which is kind of a fancy XML type of paradigm. And so what I need to do is I need to first create an audio processor value tree state, okay? So you'll see, just to get a little bit more technical, the parameter layout is something I did in the private. I just did in the private section of the class, because I don't need that to be used by any of my other classes. If I needed any other classes to use that, then I would want that to be in the public. I would want that to be up here somewhere in the public section, okay? However, my audio processor value tree state, I will need that to be public, okay? Because I need to access that when I'm creating my UI later, okay? So to do this, once again, it's a JUCE object, so it's JUCE : audio processor value tree state. I just normally call these parameters, something like that. Okay. Now to take you through what to do next. So let's say, okay, I've created this parameters. Now I just want to test it out, and I hit build. Then the cops come. Just kidding. And it gives me this error, okay? Once again, when you get errors, the biggest thing is just trying to read it and trying to really digest what it's saying, okay? So the error says constructor, let me go back to it. Constructor for Queen Mary audio processor must explicitly initialize the member parameters, which does not have a default constructor, okay? Does anybody know what that means? Okay, must explicitly initialize the member parameters. Okay, so we know that parameters, so the audio process, the processor value tree state object is called parameters, okay? Must explicitly initialize the member parameters, which does not have a default constructor, okay? Does anybody know what a default constructor is? Anybody? No? Okay. Default constructor just means a blank constructor that doesn't have any arguments. Okay. So if we take a look at, so if we go back to our JUCE documentation and we go to audio processor value tree state. Okay, and we scroll down and we look at the constructors. We know they're constructors because they have the same name as the class. And we can see here that there's a destructor here that's blank, right? Normally destructors are blank like that, but there's no version that we can create by giving it no arguments, okay? All of these say that they need arguments. Okay, so here we see this version, which is a reference to an audio processor, the processor that we want to connect to. Okay, we know, so we have an audio processor. That's this object that we're in now called Queen Mary plugin audio processor. That's an audio processor. Okay. Undo manager, which is a pointer. Undo manager to use. We could just make that null pointer. Okay. Then you have this const identifier and value tree type. This is just a string that we give it that just lets it know, like, okay, we'll call it parameters or we'll call it params. And then look here, parameter layout. It asks for our parameter layout. Okay, so it makes sense why it needs a constructor with some arguments, right? Because it needs some parameters that it's able to load and say, okay, here are my parameters. Okay, so the way that we do this is we need to do this in the constructor. Okay. Once again, it's unfortunate that you have all of this confusing stuff here that can confuse us if we're just getting started. But we need to do what's called an initializer list, which means that when we create the constructor, that it's creating the parameters object, okay, at the same time before we actually even go into the function and do anything in the function. Sometimes we say, okay, the parameters, we need to tell it, we need it to construct before we actually do anything, before we actually do anything else. So what I could do is I declare my object here, parameters, and now it wants a audio processor to connect to. Does anybody know what needs to go in here? Anybody? We know, I'll give you a clue. We know that the class that we're in right now is an audio processor. Okay, that's your clue. Okay, anybody? It's a bit of a tricky one once again. No? Okay, so they have a special, yeah, go ahead. Like self, like something like self, right? SELF. Okay. Yes. In other languages they call it self. In C++ they call it this. Yeah. THIS. This just means the class that we're in right now. Queen Mary plugin audio processor. Okay. It's asking for a reference. So this is actually a pointer. So you can see here where it says Queen Mary plugin audio processor. And then it says pointer this, but it's asking for a reference, which means I need to dereference it, okay? Give it back the value, which means that I need to put a little asterisk in front of it, okay, like that, okay? So that's the value of whatever it's pointing to, okay? Once again, undo manager is a pointer. I can use one, which means it's optional, whether you use one or not. I'm just going to make it null pointer. Okay. Identifier is just a fancy word for a string. So I'll just call this params. And then parameter layout. Anybody know what I need to do here? Okay, I'll give you a clue. There's this method down here that we created earlier called create params. Okay, so what do we do there? Any ideas? Okay, I'll give you another clue. Create params returns a parameter layout. Okay. So what do you think we need to do? What's that? Create params. Exactly. We just called the function. Create params. Oh, what happened? Yeah, I don't know what it did there. Create params. Okay. That does it. And it works because it just needs to call it once. Okay. So there you go. Now I hit build and it should all compile. Okay. We haven't really changed anything in terms of the plugin itself, but that's what we needed to do to create the value tree. Because what we need to do, it would be like if we were using XML, right? We need to say, okay, XML dot get parameter gain, right? If we were talking about XML. So we're just doing the same sort of thing, okay? So what we'll do here, I don't, here in our processor block, I don't know that this is like the best, what I would call the best practice, but we'll do this here just to keep things simple, is I'm just going to call this auto gain equals our audio processor value tree state object, which is parameters, and then dot, and then there's a method within audio processor value tree state, which is get raw parameter value. Okay, and what it does is it takes a string, which is the parameter ID. Okay, the parameter ID was what we created way down here, gain. Okay, so what we could do is parameters, get raw parameter value, and in here I put the string, and it's called gain, okay, with all caps, okay, because if it's wrong, then it won't work, okay? Now get raw parameter value returns, so let's not worry about the stood atomic part, okay? That's something, that's another discussion that, you know, we could do another time, but more importantly, it's returning a pointer, okay? A pointer to let's just say it's a pointer to a float, okay? Just to make it, just to try to simplify it a little bit, okay? So what do I replace the 0.1f with? Anybody? Gain, right? Okay, sort of. Okay. If I do that, you get this invalid, this very common error in C++, invalid operands. That means channel data at sample position is a float, and I'm trying to multiply it times a stood atomic float pointer. Okay, so does anybody know what I need to do? What's that? Right, so I need to dereference gain because gain is a pointer, and I want to get the value of what that is. Okay, so I would probably put this in parentheses just to make it not look confusing. Not turning it, but looking in, I wouldn't call it turning it into, I would call it more like inspecting what the value is. So the pointer is the pointer itself. So it's pointing, yeah, so it's pointing at a box, which is a memory, a piece of memory, and it's saying what's in the box. Yeah, which is the value of gain. Okay. Yeah. So that's what that is. Okay. Now, the thing is that I don't have anything yet to control gain. Okay. So there's one really cool tool that you can use to actually do this quickly. So let's say that you're doing some DSP, you've created some DSP algorithms like a filter and things like that, and you just say, you know what, before I do any sort of UI, I just need something just to test it out, see if it works or not. Okay, they have this class. It's called the generic. I think it's one of the coolest classes in JUCE. Very, very, very handy. It's called the generic audio processor editor class. Okay. So what it does is it actually inspects. So it looks at your audio processor value tree state, it looks at the parameters that you have, and it actually creates a simple UI. So in this case, it'll just create a slider that goes from 0 to 1. Okay, and it'll connect, and it actually does all the connections and everything. Okay, so so in this method called create editor, I can actually just replace this Queen Mary, because this Queen Mary plugin audio processor editor is talking about this custom UI that I want to create, a little bit later, right? But now what I can do is I can just replace that with a JUCE generic audio processor editor. Okay. And now what you're going to see, so we'll just try to build this. Oh, this is an interesting one that I came up with earlier. Okay, so, and I actually know how to fix this. So it says if you're this actually doesn't really give you a good clue of what's happening. You know, unless you knew the discussion that I had about earlier about when you create a parameter ID about version hints and creating like version 1 or version 2 of parameters. But we can see here that it says parameter get version hint equals 0. Okay, so this is a little bit, I think that I'm sure they must have had a intelligent reason for doing this, but we see that the version hint is actually 0. I think that the default should actually be 1 here rather than 0, but I'm sure that they had some sort of intelligent reason for doing that. So once again, that's an optional argument. That's one of those that you could, that as a beginner, or even when I was doing this last night, I ran into this. I was like, what is this? I don't even understand what this means or why this is happening, and I just want it to work. And it's very frustrating. But down here, when I created this JUCE parameter ID, I just need to give it a version number. Okay. In this case, I'm giving it a version hint of 1. Okay. You know, they should either make that, in my opinion, as a non-framework writer, they should either make version hint a required parameter, or they should give it a default of 1. But now, when we do this, we'll see that it builds. We see that it builds fine. Previously failed while loading. Would you like to load it anyway? I'll just hit yes, see what happens. Okay, and now we see our UI has changed. Okay, and it's changed because we're now using this generic audio processor editor, which actually just takes and creates a very basic user interface that we can work with, which is really cool. Okay, so now when I hit play, now I turn it down, turns all the way down. I turn it up, turns up. Yeah. So boom, you have a plugin. That's a plugin, right? Cool. So now let's do some some steps to make this to create our own user interface. Just something super simple. Okay. So now we're going to go over to the editor side, and what I'm going to do is we need to do 2 things. First thing is we want to create some type of visual element, some type of slider or dial. And then what we need to do is we somehow need to associate that slider or that dial with the parameter that we've created in the processor. Okay. So they have this class, once again, really handy class. It's called the slider class. Okay, so here's the slider class. And you have there are loads of things that you can do. Loads of things. Okay, but we'll just do the basics today. Okay, so one is that you can set a slider style. So a slider just refers to some sort of, ranged parameter UI element. So if I open up the slider style documentation, we see that there's, you have linear horizontal, linear vertical, rotary horizontal drag. You have quite a few different options there in UI elements that you can use. Okay, so we can, going back to our slider reference, looking at our different constructor arguments, we can either use a blank default constructor, or we can use one that where we give it some type of name if we want to refer to it later. So I'll call it JUCE slider. I'll just call it gain slider. Okay, and I could just do it like that because there's a default constructor. Now what I can do, once again, your constructor is where you can do things like set your slider style, define certain things that you only need to define once. Okay, you don't need to define it every, and so for that reason, you can just do that in your within your constructor. Okay, so I could say gain slider and set slider style, and then just going back into a little bit into the logic of how that works. So you have slider. So slider style is an enum, or let's just say slider style is within slider is a better way of describing it. So just to give you an idea of why the way that the syntax works the way that it does. Okay, so once again, it's a JUCE object. It's in the slider class. It's called slider style. And we'll make this a rotary vertical drag. Okay, so it'll be a rotary dial that you use the mouse up, mouse down to change the parameter. Okay, another thing that I could do is set the text box style. Okay, so that's just a text box that shows what the parameter value is, and I can just set it to a different place. So once again, text box entry position is within the slider class, just like slider style, and you got no text box, right, left, above, below. And so I could say, once again, JUCE, slider, text box, entry position. I'll just put it below. Okay. Is read only. Okay, so if you want to be able to click in, change the value, you can do that by setting this to false. Or if you just want it to be read only, you can just set it to true. Okay. The width and the height of the text box position itself, I'll just set those to 150, just kind of arbitrary values. And then there's this crucial command that you got to give it to let it know, hey, I want you to appear as a child component of my background, of my editor. Okay, editor is like the top. Remember what I was saying about the graphics hierarchy, that you have like the top, the main background, then you have other elements that you put on it. So this is just this command, add and make visible, is just a command that says, hey, I want this gain slider to be a child of the editor. Okay, my main background component. Now when I go down to resized, what I could do, so let's just change the dimensions of this. I'll make this square 400 by 400 canvas. Okay. So there are a lot of different tools that you can use to lay out your graphics components. Okay. So I could just say, gain slider, set bounds. And there's one here where it says, give it an X position, a Y position, a width, and a height, right? So I could say, get width. So that starts. So it doesn't start from the middle of the slider. It starts from the top left of the slider or the UI element. Okay, so I'm going to account for that. So we have a 400 by 400 canvas, and let's just say that I want to the text box makes it a little bit funky, but let's say I want to make it get width minus 100. Okay, get height. I'm just going to put this in the middle of minus 100, not divided by, minus. Okay, and I'll set it to 200 by 200, 200 by 200 pixels. Okay. So I'm just going to take a look at what this looks like in standalone mode. So I'm not going to load up Reaper. Just going to take a look, make sure that it looks halfway decent. Oh, see, it's still showing my generic editor. I just need to go back and I need to set that back to my my plugin editor. Okay, so the name of the class is Queen Mary Plugin Audio Processor Editor. Okay. Come on, I'll get it right one of these days. There we go. Okay, so that just set it back to this class that I've just done some work in now. Okay, once again, just going to build in standalone mode just to make sure that the dial actually looks decent. As you can see, I've put it off the screens. That's not quite right. So that's because I did get width, the whole width of the screen minus 100, the height of the screen minus 100. I want to do get width divided by 2 and get height divided by 2. Okay. And boom, there it is in the middle of the screen. Okay. Okay. Now, one thing that I'll tell you is that you have to be very careful when you're doing audio processing. You have to be very careful with your parameter ranges, your dial ranges, all of these things, because otherwise you could really, produce something that will be loud and abrupt, and if you're wearing headphones, could be potentially very dangerous. Okay, so we can see in this situation, luckily we haven't actually connected it to our parameter yet, but we can see that this actually goes from 0 to 10. Okay, we don't want something with a gain of 10 because that would just be that'd be terrible. Okay, so the reason that that's happened is because I haven't actually set any ranges in the gain slider. So I could do gain slider, set range, and I'm just going to make this 0 and 1.0. Okay, gain slider. And then there's a set value. I'll just set the value at 0.5. Okay. Now we should be the one other step is that we now need to associate this gain slider with the parameter that we've created in the plugin in the processor. So we have the gain parameter that we created, and now we need to connect that to our slider. Okay. So the way that they do this, if you look here And this is something that's gone through all types of various iterations. It's a slider attachment is the class that we want. So here we have this slider attachment. This is what actually is an object that allows you to associate a slider or a UI element with something in the processor, okay? And we can see that the only thing that it gives for you is a constructor. The audio processor value tree state to use, the slider, the parameter ID, so the actual ID of the parameter that you want to use, and the slider that you want to associate it with. Okay, so we'll just create that now. JUCE, slider attachment, slider parameter attachment. Oh. And I wonder if I could just do it here like this. I'm going to try it here first. Sometimes you can do it here. So once again, this is actually a slightly different class. So slider, parameter, attachment. Okay. And parameter, slider, and an undo manager if you want. So the parameter let me think about this for a second. Yeah, I don't want to experiment. I'm knowledgeable that I'm a little bit over time now. So rather than this slider parameter attachment, I'm going to use this JUCE audio processor value tree state slider attachment. Now I'll call this gain attachment. Okay. And once again, this needs to be, because this is an object that doesn't have, it needs to have the constructor arguments defined when it's initialized. I need to give it the audio processor value tree state to use, the parameter ID that I want to attach it to, and the slider. So, so the audio processor value tree state object is once again in this plugin processor. So I made it a public member called parameters. So the way that I would do this is I say gain attachment. So it would be the way that you access that audio, the audio processor object is this. It gives you a reference to the object here, called audio processor. Okay, so you can just access it through there. Audio processor dot parameters. Okay. The string, which is the parameter ID, once again, is gain, all with caps. And the slider is called gain slider. Okay, so now I've just associated those two things with each other. Okay, now you get this warning. Once again, very common warning. Field audio processor will be initialized after gain attachment, okay? Now that's problematic because we're trying to do something with the audio processor, but the audio processor itself has to be initialized before I try to do anything with it. So because of that, so you'll see here that I have gain attachment declared. So this is important. The order that you declare these in, okay? Gain attachment, in order to initialize it, it needs to know about audio processor, okay? Which means that audio processor has to be before gain attachment, okay? So that's something to pay attention to. And it also needs to know about gain slider as well, right? Because when I create the gain attachment, it needs to know about the audio processor, it needs to know about the gain slider as well. So for that reason, you have to make sure that you create the slider and the reference to the audio processor before you initialize the gain attachments. That's something that's very that's key there. Okay, so now when we build this, we should be golden. Okay. Oh, I built it in standalone mode. Okay. Then we'll make one more improvement, and I think we can wrap it up from there. Okay. Okay, open it. Okay, so now that works. Okay, so there's your first working plugin. There you are. Okay. So now we'll make just one more little improvement on this. Okay. So last improvement that we'll make is that so you know that in Reaper and any DAW, the range is in decibels full scale, right? So it's not going between 0 and 1. It's going between like -60 and 0 or -60 and +6. Does anybody know why that is? Why gains in DAWs are in this weird decibel full scale rather than between 0 and 1. Anybody have any ideas? Good. We perceive volume what? Yes, because we perceive volume logarithmically. So what it is, it's actually a equation that allows us to that maps to the way that we actually hear sound. So probably most of you know that when you're that at low volumes, you can hear big differences in the sound. So if I clap my hands very softly, like this, I clap it a little bit louder, like that, you can hear a big difference between that. But if I do this, and then a little bit harder, like you can't hear a difference between those two, right? Like so the louder that volumes are, the more that our human ears just say, oh, I don't know, it's loud and, loud. So somebody very smart said, okay, we need algorithms that help map the way that we hear sound, because what happens is that, once again, when you're looking at 0.0 to 1.0, what you're going to do is you're going to hear the range of your slider is going to once you get to, you're going to hear a difference between 0 and 0.8, but then you're going to have a very small range of your slider that's going to be vitally important for like people like mix engineers. That's going to be between 0.8 and 1.0.
It's going to be vitally important for sound engineers, but you're not going to have much room to be able to tweak that sound. So what they do is they've mapped it to how we hear sound logarithmically. So the way I'm going to do this is I'm going to take the parameters and I'm going to change the range of it from -1 and instead make it -60 and then make the maximum maybe 2.0. Okay. And then once again, I'm going to like make it maybe the default maybe be -10, right? Okay. Now, once again, you have to, this is a place where you need to be very careful that you don't give it, that you don't accidentally give your parameter a value that does not make sense. Okay. So this is important because you need to change your gain slider range as well. So -60. And you can actually make it where your gain slider just grabs from whatever the parameter range is and automatically populates that. Okay, but I won't worry about that for now. I'm just going to set these for now to the same settings. Now the only other thing is that, okay, we want to make sure, and this is the part where you can once again really mess something up, because if my maximum is going to be 2, but I'm still doing this and just multiplying raw values, now I could potentially give this gain value a volume of 2, which will sound very loud and very abrupt within a pair of headphones and could potentially damage your ears. So don't do that. So now this is going between -60 and 2. And JUCE has these great utility math functions. One of these is called JUCE decibels to gain, or actually it should be, yeah, decibels to gain. See, I almost messed it up myself. Okay. And now I should actually probably change my, just to make sure that this is not confusing for people. Maybe I'll just call this dB. I'll make this a capital D, actually. Okay. Now I just need to change this all around. dB. Oh, sorry. I'll keep this dB. Sorry, I'm getting myself wound up. This workshop is getting too long now. Okay. So now I've got it. Capital dB, lowercase dB. That should be. Why is that complaining? I'm just getting my parentheses messed up. Second, might need to. Now, I think it just doesn't like that I'm trying to do all of that at once. Or actually, can I just do this? Float. Okay, cool. I just had to create a regular float from it. Which is better anyway. Okay, now I just need to go to the editor. Change this to DB. Okay. Now I think that at least last I checked, if you try to find a parameter that doesn't exist, it doesn't really give you any clues that that parameter doesn't exist, and it just says, I don't know what's happening. So just watch out for that. Make sure that the value, the gain ID that you give it is. Okay, great. That sounds helpful. So see, it's -10. And see, now that's a nice linear, or it's actually a logarithmic mapping that makes it feel linear. There you go. Okay. So great. So that's basically it. I mean, you can extend off of this in a number of different ways. One thing, for example, you may want like saving state and loading state, so that gets into something else. Another thing is that with certain parameters, you want to have them smooth so that they don't change too quickly. So you have like a linear smooth value class that's really handy in JUCE. And there are loads of different ways that you can extend off of this. But this is just an overview of how to create your first one. And it's something that feels like it takes a very long time. But once you've done it a couple of times, you just get into the flow, and then normally you'll have a couple projects where you already have these things set up. You have the scaffolding, you don't have to write it all from scratch, and you just bring it in, and you start creating your own little helper library, and everything starts getting quicker from there. Great. Any questions? Any questions, comments, concerns, feedback, anything? Anybody? Okay, no? Oh yeah, I can make that available. I'll upload it to my GitHub, and yeah, absolutely. Absolutely. We'll be happy to do that. Yeah. Anything else? Anybody? Cool. Thank you very much. Thank you for being amazing students. I hope you enjoyed this.
Thank you so much, Josh.
Yeah. Cool. And happy hacking. Happy hacking. Yeah.
I think we're having a launch off at 4 p.m. in about 40 minutes.
Ooh, sweet.
Coming up.
Yeah. Looking forward to it. Yeah. Thanks a lot, everybody.